James here from Northwest HVAC in Spokane, Washington. Here we have our third part of our three-part series on recovery, evacuation, and recharging. I apologize it took so long. We got shut down for COVID, and then the guys came back and things were kind of hectic. And then the summertime happened and I got out of here for a while. And then when the school year started back up, I actually did record this third part a while back. But then when I went to edit it, some of the files were kind of messed up. So I redid it here first week of March 2001. And now it'll be on the internet forever. So you guys can't complain about how long it took. So here you have it, the recharge process. Okay, so the first thing we want to do is check the label. I know we got 5 something out of it, but it could have been overcharged. We don't know. We're going to check the label. So as we see here, zoom in, we see right here, factory charge, 60 ounces, 410A. So that comes out to 3.75 pounds. So that's what we're going to put in it, give or take a little bit, adjusting for subcooling. Okay, so we would still be in a vacuum at this point. Gauges are closed. We're getting ready to recharge this. I got my scale, got it set to 0. I'm on my tank, and that's all I've done so far. I haven't purged anything, I haven't hooked anything up yet, or any of that stuff. So we want to start by purging it here. Let's get our tank on. There we go. Okay, so I have refrigerant up to that point. And I closed off my low loss, or my valve core remover tool, because this is actually a simulation right now. And I did something with it a little bit ago, so I need to purge the air out of this red hose too, and it wouldn't kill you to do that anyway. So we're going to open this. We're going to purge down here on our valve core tool. Make sure we got liquid spraying out. Okay, so now we're ready. We're purged up to there. What we want to do now is we want to be able to get that valve core tool off that I put on there when I was pulling a vacuum. So what we're going to do is we're going to charge up just a little bit, so it's up 5 or 10 psi on both sides, and then that'll be, pressure will be low enough for us to dismount things, put our valve core back in, and put a regular low loss fitting on to continue that way. You don't want to do this while it's in a vacuum, clearly, because you'll be pushing air in there when you put the core back in. So first thing we want to do is we want to add a little bit of juice to the system. And it looks like just what I had in my hose was enough to bring us up out of a vacuum. So that's what's kind of nice about preloading that red hose when you have the valve core tool on there, is we preloaded up enough that it shoved enough refrigerant in there. So we're now out of a vacuum, so we're able to take that core tool off, put the core back in, which I'll show on another video. And we'll get our regular low loss fitting on there, and then we'll finish charging this thing to that 3.75 pounds that it's supposed to hold. And also make a note, it put 4.5 ounces in just from purging the yellow and the red hose. And so we had talked already in class how the hoses will hold a couple ounces each. All I did was a hose amount into that unit, and it's 4.5 ounces. So keep that in mind when you're working on something small. Always use your stubbies on something small. So I'm going to switch over to the regular low loss fitting, and then we'll continue. Okay, now that I got this core tool off of here, I put my low loss fitting on. I purged it back from the machine just a little bit, not enough to matter in terms of ounces or anything. And then that way my tank stays at the 4.5 ounces we already took out of it. So now what we want to do is we want to try to shove in as much as we can up to that 3.75 pounds that we needed, which would be, this one does pounds and ounces, so that would be 3 pounds, 3/4 of an ounce would be 12, or 3/4 of a pound is 12 ounces. So 3 pounds, 12 ounces where we want to go. Sometimes it'll take it all, sometimes it won't, so let's find out. And while that fills, one thing I didn't mention was I hooked it on the red here on the tank, because this being a blend refrigerant, pretty much all refrigerants nowadays, you want to charge them as a liquid. You don't want to charge them as a vapor. So although we recovered into the vapor side because it's easier, we're going to put it back in from the liquid side, so that we make sure it doesn't fractionate and mess up our blend or anything. So I can see here I'm about 2 pounds, 3 pounds. We want to stop at 12 ounces. Looks like it's going to take it all. Sometimes it won't. I'm going to stop a little short on purpose. Stop at 3 pounds, 10 ounces. Well, we'll end up having to put more in anyway, but usually if there's not enough pressure in your tank, it won't take it all. So what you have to do is then you have to fire up the machine and you have to flash it in the low side through a flashing process. So I want to show you that process. So I'm going to zoom in a little bit and fire up this machine and kind of show you that flash-in process. I have a feeling we're going to need to adjust for our subcool anyway. So that being said, let's go ahead and take it up to the 12. Okay, 3 pounds, 12 ounces, exactly what the label says. But remember, there's all kinds of factors: coil size, line set size, all kinds of different factors that can contribute to you having to add more than what's on the label, and that's what we're going to find out here in a minute. Okay, so now I've zoomed in a little bit so you guys can see my stuff. You see the scale on the right, 3 pounds, 12.75 ounces. That 7.5 is not going to kill us because I have a feeling we're going to have to add some more. We did pull 5 pounds out of it, remember? So I also set up my temperature probe. You can see my liquid line is 63 degrees, it looks like. So right now I'm going to compare it to my temperature on my high side gauge, which we could see is with 410A, it's looking like about 66. So that would be the pink there. About 66 degrees, 63 degrees on my meter, which means we're getting zero subcooling pretty much. I mean, negative, so I mean, it's not condensing all the refrigerant really. So we need to add some. But first thing we need to do is, it's not 90 degrees in this lab. And these things are designed to operate properly on a 90-degree day. So we're probably underfeeding our evaporator coil. Our TXV is not feeding properly because the head pressure is not high enough. So what we want to do is we want to take some plastic. I like to use ripped up trash bags, which by the way, we keep already ripped here. So stop ripping my new bags and find them off the carts. Okay, thanks. Public service message. Now, moving on, let's get this thing wrapped and see if we can get that head pressure up a little bit. And then we'll check what our starting subcool is. Okay, we got that wrap on there. You can see the black plastic now behind my gauge. Field piece makes a nice, what they call a charging hood that goes over the top. So you could put something on top too, like some cardboard weighed down with your recovery machine or something like that. I find it simple enough just to wrap a trash bag around the outside. What we're doing is we're blocking the airflow so that the head pressure will go up, so it'll simulate a hotter day. And as you can see, it's already hotter on my temperature probe. That's reading from here, it looks like it's almost 100. Yeah, there it is, 100 on the temperature probe. When we zoom in, you can see my liquid line went up. I didn't change anything. All I did was bag wrap it to simulate a hotter day. 100 degrees on the temperature probe, and if we zoom in on the gauge now, you can see the gauge now in the pink is reading about 102. Each one of those lines on there is 2, because we got 100, 110, so that's 2, 4, 6, 8, 10. So that's reading about 102 and about 104 on my liquid line, which means we still have negative subcooling. So that means we need to add some. So what we're going to do is we're going to just flash it in. Like I said, once it's running, you can't just dump it in there because you're dumping liquid right in the low side. So you have to use the flash in method, which works kind of like this. Check out this low side gauge here. We're going to pump it in for about 2-3 seconds. It's going to rise, and then we shut it off and let it settle. And we got to boil all that liquid off of there. Or else if we just open this wide open, we'll slug our compressor. So since we have to put it in the low side, the high side pressure exceeds our can pressure. So we can't just dump it in there. We have to flash it in the low side. And you can see it took another 3 ounces. So I'm going to take it up to, since it had 5 in it before, I'm going to take it up to about 4 pounds, 4 ounces. All the while I'm going to watch my temperatures. I currently have a 104 on my high side and a 114 on my pipe, which is again backwards subcooling. So once I get this close, we will see these numbers kind of correspond a little better. And no, Field Piece is not a sponsor, but they should be, because I usually only use their products. Alright, so I like when nice little mishaps happen, so that I can show you guys some things that can happen. So I wanted to use these particular gauges because they're the same kind as what you guys receive when you go to school here. And mine are kind of old and crappy. And what I noticed is the bottom part of my needle, this little arrow thing right here, was actually bent in a little bit, and it was bound up on the adjustment screw. So that's why we were showing negative subcooling. So all I did was unbend that, freed up that needle, and now as you see, we're looking at about 112, 114 on the temperature now in the pink there. And as you can see on the meter, it's about 107, 108. So you do the math on that, it's about 6 degrees of subcooling. Here, I'll see if we can get this a little closer, clearer, so you can see it. We are 2.5 lines above 110, which puts us just about exactly 115. And we got 108 on the meter, so that means we need to add some because we want to have 10 degrees of subcool. We're going to add a little bit more. Remember, I pulled 5 out of it, so maybe that wasn't too far off. We're going to add a little bit more, flash that in, let it settle, and then we got to let it run for a minute and compare our temperatures again. Looks like I'm at 116 on the high side. We're holding about 109 on the liquid line. Flash a little more. And I'm going to repeat that adding process, and I'll have you guys take a look at it here in a second when I get it about where we want it. Flash some more. Alright, I'll get back to you in a second. Alright, so there you have it. I don't want to go too much further. We're pretty close here. We got about 113, 112, 113 on my, looks like 114 now on the temp. And we're about 124 here on the temp on the 410A. So at that point you're done and you need to disconnect. So there's a little trick to getting your gauges off of here without losing a bunch of refrigerant to the atmosphere. So I'm going to show you that. Also note that we ended up at 5 pounds 1 ounce, even though it called for 3.75, 3 pounds 12 ounces. We ended up putting almost an extra pound in there because we have a bigger indoor coil and possibly a little bit longer than design line set on this guy. So now at this point I'm going to zoom back and you guys can see how that detach process works. Okay, so the idea here is this yellow hose is still full of liquid from the tank. This red hose is full of liquid from the system. If we just simply detach, all that liquid's going to blow to the air, and the EPA is going to be mad at us. Plus, we'd rather put that refrigerant into the machine and not waste it, because it does cost a little bit of money, but mostly so the EPA doesn't get mad at us. Now, the process here is pretty simple. We want to shut off the tank. Tank's off. No more refrigerant can flow out. The next thing we want to do is detach the red from the machine while it's running. And we use that low loss fitting, so as you can hear, almost nothing came out. So now this is loose. Don't do anything with it yet, but you don't want to drop it in the dirt, so what I usually do, kind of set it on my tank like that, or I'll kind of set it up here over the top of my gauges like that. You know, something to keep it out of the dirt. I want it out of my way for now, so we're going to put it on the tank. Now, as we said before, that hose is full of liquid, this hose is full of liquid. So, we have to get that liquid out of these two hoses and back in the system. So what we're going to do is open up red and blue here, and we're going to let the low pressure side of the system suck it out of our hoses right into the low side of the system. You'll see that needle will go up, and it'll never come back down to zero. Right now it's at about 120 psi. That's all the lower it's going to go. So it'll come up for whatever the high side pressure is, then it'll drop back down to that 120, and then you can detach, and when we're done, you'll see we'll get almost no liquid out of these. So open these up, both of them. Let that low side suck all the refrigerant through. If you don't use the low loss fitting, you can't do this. So the needle's going to bounce a little bit, and then it's going to settle, and oops, come on. There we go. Once it settles, we can close that. If you don't use that low loss fitting, you're just going to detach your hose. It's all going to spray. So you take that off. The refrigerant will still be locked in the hose. It'll be locked in this hose. Turn this off. Take that off. Open both of these. Let the low side suck it through, and then you're ready to detach. Nothing but vapor on that one. And we're not currently hooked to the system anymore. You put your stuff away, put your caps on, don't forget that. Write your invoice. And if you did this properly, you shouldn't get much of liquid out of here. See? Very little. It's just basically a purge, not a big stream of liquid. Same thing on this one. Pretty much just a purge. Alright. So, there you have it. Recharge. Alright, there you have it. So that was recharging an air conditioner after a vacuum. A couple things. I had to simulate it this time a little bit because these videos were so far apart, and as I said before, I had to redo this one. So it wasn't actually truly in a vacuum when we started. But I did go through the process of removing the Schrader core tool and switching over to the low loss fitting, which I will make another video of here soon on how to use that core tool to change that core out and get your machines all set up with it. We also had a little mishap where my gauge pointer got stuck on the adjustment screw, so we got that figured out. That was no big deal. And you also got to see how we have to simulate design conditions, which is a 90-degree day. Our lab here is like it's 60 in here right now, I think, and obviously not 90. And then also got to see that we might not actually have to have the charge that's on the label. We may have to add some refrigerant based on length of line set, size of indoor coil, and some other factors. So I think other than that, it's a pretty straightforward process. Just make sure you purge your lines properly so you don't put air back in there after you pull a nice vacuum. And at any point through any step, if you're ever concerned, you know, when in doubt, purge. Remember never to open your red or blue hose at the manifold while the machine is in a vacuum, or you just blew your whole vacuum. So your purging needs to happen between the tank and the manifold through the yellow hose, and then everything should be good for you that way. Thank you.